In this lesson, we are going to have a little look at the derivative of ln x, and I just wanted to remind you that ln x, the natural logarithm of x, is basically log base e x. So here we go. So we're given a function ln x, okay, the natural log of x, log base e of x. Then the derivative is 1 on x. Would you like to know why? Well, feel free to YouTube it because it is a fairly complex reason why it turns out to be 1 on x. So I'm not going to cover it in this video. Instead, we're going to get straight into examples. So let's have a look at example 1 here, which is 2 ln of 2x. So I've got a very light touch use of the chain rule here. So first things first, let's get to y by dx happening here. Now the 2 is a constant, so therefore we can just sort of find the derivative of the next bit along, so the 2 stays there. And the derivative of ln 2x, so we find the derivative of the whole thing. The outside function is ln, the inside function is 2x. So let's derive the whole thing first with respect to the inside function, so that's 1 on, and the argument was 2x, so it stays there. And then we find the derivative of the inside function, which is 2x, which is 2. Okay, now this 2 and this 2 cancels out. And so we're left with 2 times 1 on x. I'm going to write that down. I'll explain why in a second. So left with 2 times 1 on x, which we can then simplify the 2 on x. That is our answer. Now here's the bit I wanted to point out. This bit here, 1 on 2x times by 2, the 2's cancel out. Can you see that? I started off with ln 2x and I end with 1 on x, even though I had a number in here. And so we have this kind of little side note here that if we find the derivative with respect to x of ln of kx, then we can basically say that is just 1 on x anyway. It doesn't matter what k is as long as it's a number. So ln of pi x is 1 on x. So the derivative of ln pi x is 1 on x. The derivative of ln root 3x is 1 on x, etc., etc. They'll always be 1 on x because the derivative of the inside function will always just be that k value, which will then cancel out. Okay, so it's a little shortcut if you can remember it. But if not, of course, just using the chain rule will get you there anyway. I'll leave it zoomed out now so you can see it. Example 2, the square root of 1 plus ln x. Let's do a little bit of busy work so that we know how to deal with it. Just turn it into a power of a half and then chain rule away. So the outside function is a half. So the derivative of that will be bring the half down, write the inside function as is, and subtract 1 from a half to get negative a half here. And we're going to multiply it by the inside function, which is 1 plus ln x. The derivative of 1 plus ln x is, well, the 1 disappears, ln x becomes 1 on x, and so it becomes 1 on x here. Now I'm going to take the half here and multiply it by the 1 on x here, and I'm going to get equals 1 on 2x multiplied by 1 plus ln x to the negative a half. And I'm just going to go hell-bent for leather now. 1 on 2x, that's the denominator here. That's a negative. That's a denominator. The denominator here. That's a negative a half, so it's going to become a positive a half underneath. And then I've got 1 plus ln x with the square root sign there. Now, if my jump from there to there was too much, ask me in class, and I will explain. I'll go through it a little bit more slowly for you. Okay, next one. Y is equal to 1 over ln x. Well, again, we can't solve this directly using the techniques we've covered so far. We've got 1 over, so it's not in the right format. So we are going to use our classic trick of bringing it up to the top and raising it to the power of negative 1. Okay, now that we've got that, we're going to use the chain rule again to bring the negative 1 down, and we keep the inside the same. Subtract 1 from the power to make it negative 2, and then I find the derivative of the inside, which is ln x, which becomes 1 on x. Okay, tidying that up, I've got minus 1 on x. That's just multiplying those two things together, and I'm going to multiply it by 1 on ln x squared, like so. And now I'll just make it one function like so. You might notice that sometimes when I'm doing this, I sometimes forget to put the brackets around the x and sometimes I don't. My preference is to put brackets around it to remind you that x is the argument for the ln function. Argument means it's what I pass into ln. But I have to say that it is a very common notation not to put brackets for sine, cosine, tan, ln. Because it's so common, it just sort of cuts down on the number of brackets you have to write and see. But do note, it does not mean ln times x. It does literally mean ln of x. Okay, so that's example 3 done. Moving on to the next one, just a couple more examples, and that will be finished up. Ln of 1 on x. Okay, there's actually a few ways you could do this. So I'll just do the most vanilla approach first, and that is take the derivative of ln x. Okay, so the derivative of ln is 1 on. So in this case, I'll have 1 on, and what was there? 1 on x. So now I'm going to have 1 over 1 on x, and we'll deal with that in a second. And then we'll find the derivative of the inside, which is 1 on x. And just a reminder, I should have done this beforehand, 1 on x equals x to the negative 1. And so we're going to have negative 1 x to the negative 2. So I've used the chain rule again to find the derivative of the whole. There it is there. And then the derivative of the inside. And there it is there. So tidying that up, what have we got? Let me think. 1 divided by 1 on x. I'll do this off to the side as well. 1 divided by 1 on x is the same as 1 divided by 1 on x, which is 1 times x, which is x. So this effectively becomes x multiplied by negative 1 on x squared, and then they will cancel out to give me negative 1 on x. So there you go. Negative, all that hard work to get to negative 1 on x. I could have made my life easier by starting the problem in a slightly more efficient way, I suppose. If I'd started off with this, like so, and then gone, well, that's equal to ln of x to the negative 1, like so, and then use my log laws to say, well, if we've got a power here, that can go in front, then I would have had negative ln of x, and then I could work out the derivative. I'm terrible for not writing it down, aren't I? I should have written it here as well. And then I can write the derivative as negative, and I know what ln x is, it's 1 on x. So that would have been probably a tidier way of doing it, less complicated. So again, wherever we can, we will try and make our work as efficient as possible by thinking about how I can prepare my problem before I go about doing it. Now this one here is an example from the textbook. It's not the same, but it's similar. And I want you to pause the video for a second and have a think about how you might approach that. Okay, if you pause the video, you might have made some headway with it or not. It looks more complicated than it is. You're given some values, f of 0 and f dash of 0. You're given a function to differentiate with respect to x, ln of f of x. We just apply our usual logic, but we just got to be careful what we're doing. We need to find the derivative of ln of f of x. So f of x is just an inside function, and ln of f of x is the outside function. So the ln of f of x, I'll get my brackets right here. Feels like there's too many brackets there. By dx is going to be differentiate the outside, which is ln. That's 1 on, and what was the inside? F of x, so 1 on f of x, multiplied by differentiate the inside, which is f of x. And we don't know what f of x is, but we know its derivative must be f dash of x, right? So it's f1 on f of x times f dash of x, or, in summary, f dash of x over f of x. That's all that means. Given these facts here then, we can now evaluate. So at x equals 0, we have f dash of x, which is, oh, well, let's just go one step, even though we don't really need to. F dash of 0 over f of 0. And then what is f dash of 0? F dash of 0 is 1, so we've got 1 on the top. And, oops, wrong way around, sorry. We've got f dash of 0 on the top, which is the value 2, and we've got f of 0 on the bottom, which is the value 1, so we end up with the value 2. So there you go. So it kind of looks complicated, but it's not really. It's just that what makes this complicated is that if you don't actually understand what is happening in this part here, if you don't understand the chain rule, then you won't know that this kind of process is the way we go. But if you just follow your fundamental understanding of how the chain rule works, and then what the ln of a function would be, therefore, You can't go too far wrong. Good luck. Try as many problems as you can.